Welcome to the assignment number 4, and the problem number is 3. Here in this problem we have to check the given array. We have given by the one array and the sum. The sum is nothing but 33. Here the problem is we have to check whether the given number is any sub array of this array is equal to the any sum of the sub array is equal to the given number or not. So to implement this solution, we can use the two types of implementations. We can see. The first one is we can check the. We can do one thing is we can just add all the sub arrays of this given array and check the sum of all the sub arrays. Either one is matches is equal to the given number or not. If that given number, we can return the indices of the sub array. That is one type of solution, but that is not efficient because the time complexity of that approach is order of n square, because it travels from n minus 1 to the entire array, and then it starts from here, and this is one sub array, then it moves to the next, and it has to do all the sub arrays from here like this. It can be like n minus 1 and minus 2, and then it up to the 1. All these sub arrays it will take nothing but n into n minus 1 by 2 is equal to n square. So the time complexity of that solution is n square, which is not efficient. We can use one efficient way is by using the pointers. Now I am taking this array, and the given sum is 33. So if I use the pointers, let's say for example this is the left, this is the starting point, and it is an okay, this is the starting point and it is the end point, and take one variable like current sum, initialize with 0, and then what I am doing is I am going to add each and every all the elements with starting from here. First I am going to check that array of endpoint is nothing but, now it is 1 0 is equal to the current sum. Is current sum or not? No, it is not, and it is less than current sum. So what I am doing is I will just move this end pointer to here, and I add these two elements which is equal to 5, and I assign this 5 to the current sum. Now current sum is become 5. Now I check again the current sum is equal to or greater than sum. No, both conditions fail, so that I do again add current sum with the next element of the array, which is 20, and it will become 25. Then I add again the current sum is equal to or greater than some given number or not. So both conditions fail. So then I move this I do traverse from here to the next. Now the endpoint is here. Now all the sum of the, I add this endpoint to the current sum, and it will become 28. Now I check the condition again. If the 28 is greater than or equal to the sum, both conditions fail. So now again I add to the end pointer to the here, and I check whether the condition then I put that current sum into the entire sum into the current sum. Now it will become current sum 38. Now I check the condition again. If the current 38 current sum is greater than or equal to given number. Yes, the current sum is now greater than equal to sum. Then what I do, I move from starting point. So it is greater than, so if it is equal to the current sum, then I return the starting and end pointers, end indexes, that which is 1 0, but it is greater than. So what I do means, I move from I move this starting point from here to the next element, and I deduct this number from the current sum, which is 38 minus 1 become 37. I check now, again I check this current sum value with the given sum. Now 37 is still greater than 38, not equal to 30. Then I do again move the starting from here and deduct this from the current sum. Now 37 minus 34 equal to 33. Now I'll check the condition again, that 33 is equal to the given sum or not. Yes, the current sum is equal to the given number. So now I return the starting indices, which is 2, and end point, which is 4. I return these two indices and I print them. Print 2 and 4. From here to here, if we see the sum of the elements, 20 plus 3 plus 10, 33 is equal to given number. Then we return this thing. So for this solution, if we implement like this, then the time complexity is, we are traversing from entire array from starting to end, which is nothing but order of n, and plus we are again traversing from the all elements with only one extra time, like I mean totally we are traversing 2 times. All the elements we are traversing only 2 times. So again order of n we are using, so which is nothing but order of 2n, which is nothing but order of n. So for this solution, the time complexity is order of n. The space complexity, we are not taking extra space, so the space complexity is order of 1. So in my perspective, this is the efficient solution for this problem. For this, the code which I implemented by using this for loop and while loop. So for the traversing from now I've taken this I'm giving parameters into this function array, the size of the array n, and the given number, given sum. Now we are using the variables. Now I am using the for loop, and in the for loop I'm checking the condition 2, like current sum is greater than or equal to given number or not, and also is it less than the starting point, which is less than to I minus 1, iteration minus 1. Then if we condition true, then we increase the starting point, and if the current sum is equal to sum, then we enter into this condition. If we are using if condition, and if it will print the starting point and end starting point and the pointer, then iteration which ends nothing but 4 in this example, it returns 1, then it comes out of the loop. Otherwise it is still going to add if I is less than n, that means iteration endpoint is less than length of the array, it will add the current sum to the next element of the array. If none of the conditions are true, it come out of the loop and print no sub array found. This is my approach.